Okay. Today we will do tutorial 5, which is vector spaces, subspaces, the span, basis, dimension of the vector space type. First, what is a vector space? We want to know. We knew what are vectors, but what is a vector space? A vector space is a set of vectors. يعني عندي vectors, okay? مثلا this is V1, this is vector, another vector V2, V3, V4, V5, V6, set of vectors. Okay? These vectors اللي هم هنا ديل, they should satisfy certain conditions under two operations. The first operation, we call it the addition, and the second operation, we call it the multiplication. These two operations could be our ordinary addition of vector and ordinary scalar multiplication of a scalar طبعا times a vector. Okay? Or we can define a certain way for these two operations. يبقى احنا عندنا two operations. الأولى addition on these vectors. Okay? And the second one is a multiplication by a scalar, either to be defined as our usual or ordinary way, like ordinary here كانت بيقول شنو, if this is a vector and this is a vector and we want to add them, what we do, we add this to this and then we get the resultant, correct? Here. And then this one to this one, and then we put the answer, etc. So this is the ordinary addition of two vectors. What is ordinary scalar multiplication, a vector by scalar? We had it before. If we have C1 and then we multiplied by this one, so and here طبعا certain elements, okay? طيب. So we're going to get C1 times this element, C1 times this, correct? This is how we define the scalar multiplication, correct? So this is going to be our new vector and etc. طيب. فيبقى this set of vectors, if we defined on them these two operations, they should satisfy 10 conditions. If the 10 conditions are satisfied, then we call this a vector space. You got it? We call it what? Vector space. Type. Okay. What are the 10 conditions? 5 of them are defined for the addition, and the other 5 are defined for the scalar multiplication. What are they? Okay. A real vector space is a set of elements of vectors V together with two operations. Here, addition and scalar multiplication should satisfy the following properties. For the addition, these 5, and for the multiplication, these 5s below. These 5 below. Type. What they should satisfy, I'll tell you. Let's assume this is our vector space. Now, let's talk or consider the first operation, which we said that the addition, we call it the addition between vectors. Okay, so if this is a vector V1 and this is another vector, okay, take them arbitrary, any two from this space. If you added them using this addition, then the new vector, let's call it V3, it should be included in this space. You have to find it here. Let me give you some examples في الريل بالنسبة للreal numbers. مثلا if I'm considering the set of مثلا integers z. What is the set z? Set z النمبرز بتاعته اللي هو النيجاتيف والبوزيتيف ومعاهم الزيرو، صح؟ positive and negative numbers, correct? طيب يعني مثلا minus 3 minus 2 minus 1 and then 0 1 2 3 وهكذا، correct? Going like this up to infinity and here طبعا up to minus infinity. طيب take an operation, okay, اللي هو normal مثلا addition. This is not vectors. I'm considering just to remind you. طيب let's take the addition. If you took any two numbers, for instance, a minus 1 or 2, is the result among these numbers or no? Is the answer if you took any numbers, فمثلا like minus 1 plus a 2, what is the answer? It is 1. هل 1 is a member here in this set? Yes. And this is the same for any x1 and x2. You took them from z. Always, if this is a real number and this is this is an integer and this is an integer, their addition is an integer as well, belong to z. So we say that this operation is what is closed. Addition is closed when في z. Why? Because if I took any numbers and added them up, the resultant is an element there. Yes? طيب. Now, what if I said multiplication مثلا by any real number? هل the result C1 في X1 as well always should belong to Z1, where C is any real number? Could the result belong to Z or no? For instance, if we took half and we multiplied times any number here, for instance, if I multiplied, طبعا if I multiplied times minus 2, yes, بديني minus 1, and minus 1 belong to this set. But is it okay for all, or for some I am going to get a number that does not belong to the set? For instance, if I took half times 3, the answer is 3 over 2. 3 over 2, is it an integer? Does not belong to z. So in this case, we say that it is not closed under what? Under scalar, مثلا multiplication, correct? Because the answer is not an element in this set. Yes? Is it clear what we mean by closed now? Okay. Now, let's come back to our vector space and the set of vectors. For this set to call it a vector space, for the first operation, there are 5 things should be satisfied. What is the 5? The first one, that should be closed under addition. That means what? If you took any two vectors, the vector الأولاني V1, and you added to it the second vector, the resultant of this should be what? Should be an element here. يعني should belong to my space of vectors. Let's call it capital V. يبقى should be closed under the addition of vectors. For any arbitrary, vectors, يعني if I took V2, V3, add them up, the resultant should be here. شلت V5 or V7, the resultant should be for any two vectors. This should be satisfied. So this is the first condition. The second condition, if you added this to this, is the same as we add this vector to that vector. So that means should be commute. يبقى the first one اللي هي احنا we call it closed. Actually, it should be closed under addition. And this addition should be commute. Correct? يعني إبدالي. U plus V the same as V plus U. Also, this addition should be associative. عنده الخاصية التجميعية. You can start with adding any two. If you add this to this and then add to it this one, is the same as if you start adding this two and then this plus that. So it should be associative. The fourth thing, sorry, we should have the zero element such that it should be here, this element. So when you do V1 plus this, the resultant should be V1. Yani this V1 0 should belong to your set. اللي هو اسمه شنو هو identity. So the identity should be one of the element of this vector space, of this space, or one of these vectors. Okay? يبقى we should get the 0 as one of these elements. More, for every vector, you should get its, and where we can say the inverse of it. If we have V1, I should get also minus V1. Okay, such that when you add them, you get this, اللي هو a 0 vector. Okay, so for every u in the vector space, then should be there is minus u. What is the vector minus u? It is the vector that when you add it to this one, you should get the 0 vector. يبقى in this space مفروض يكون في شنو؟ there should be the identity element. Okay, and mostly طبعا اللي هو the 0 vector if we are talking about our ordinary addition. And also what? We should have the inverse of this vector, which is minus V1. Actually the vector which when we add it to this vector, we're going to get the 0 vector. Okay, so all these 5 conditions should be satisfied. يبقى كده we finished with the addition of operation of addition. And this is for شنو? 2 vectors. Any 2 arbitrary, any 2 vectors. You took them, they should be, when you add them, you should find them where inside V. U plus V should equal to V plus U. It is associative like this. Okay, and now the 0 vector, okay, an identity element for this addition should be an element in this space, and the inverse should be an element. Okay, inverse as per which operation? Per this operation should be an element in this set. طيب. Now we go to the second operation. Type. Okay, so this is my space which has the vector inside it. Now we want to consider the other operation, this one. Actually, it is a multiplication by what? By scalar C1. Not vector times vector. It is vector times the scalar. Okay, there are 5 conditions as well should be satisfied. What is that? If V1 is a vector here, V1 is arbitrary, so as well you have to find C, you know, 1 مثلا of V1, where C is any real number. This is belong to the real numbers. So any real number, when I multiply times this vector, the resultant as well, it should be inside this space. Clear? No matter what is the vector, V1, V2, V3, لأنهم arbitrary. أنا بتكلم عن arbitrary. So for any vector, okay, any real number you multiply times this vector, you're going to get a new vector. This vector should be included here. So it should be closed under scalar multiplication, this vector space. This is the first. The second, if you add it, احنا طبعا we said that if V1 and V2 are here, then their addition as well is here. Not only that. Okay. R times a constant times their addition should be there, and not this only. This should be equal to R, and it is distributive. This R, it is distributive over the addition of these two vectors. That means this, you should find that it's the same as R phi U plus R phi V, like that, where R is a scalar, capital U, capital V are the vectors. Okay? That means the scalar multiplication is distributive over the addition of the two vectors. Moreover, if we have the vector U و R و S are two scalars اللي هم like مثلا let's say 2 5 فمثلا 2 plus 5 times any vector U مثلا 1 3 okay خلينا ناخد في ال R2 okay so you can add this up 7 and then you multiply after that, so this is going to be equal to 7 3 في 7 21, correct, like that. Or else what you do, this is should be equal to the same as when you distribute, so 2 times 1 3 plus 5 times 1 3, okay, and you're going to get the same result, okay, and he's 7 at 21, correct. So it is R plus S, this is scalars, times V is the same as this one here. Okay, and also if we have them multiplied, that is what 2 times 5 and then times what times U اللي هو 1 و 3. Okay, what you do, you can multiply them first 10 and then you multiply 10 here and here, or else this is the same as what, leave the 2, multiply first al 5 times the 1 and 3, correct, the vector 1 and 3, get the result اللي هو حيكون شنو، خلي 2 out first and then 5 في 1 by 5 and then 5 في 3 15, correct, and then after that multiply the 2. Okay, so either I start multiplying the scalar where here here, multiply the scalars and then multiply times your vector U, or else one of them times U, then the resultant you multiply times R. طبعا definitely. Okay, the last thing, this vector, if you multiply it by the number 1, you should get the same vector. Clear? If all these 10 conditions happened, satisfied, then this set defined on it, these two operations, we call it what? A vector space. And now he gave you here some examples. So to prove it's a vector space, you need to prove all the 10. Okay? Type here, he gave you something, and now you can take it as theorems. Type the set of vectors in Rn together with the standard operations of addition. So that means the normal way of adding vectors. لما نقول لك الستاندرد operation, that is the normal way. هل في another ways? This is if he defined for you a new way. We will come for that. طيب. And the multiplication by scalar اللي هو standard way of multiplication by scalar. Okay. So this is always is a vector space. That means what? If you took R2 and you define the standard way of addition of vectors and the standard one, the standard operation بتاعت شنو of scalar multiplication, then this is what is a vector space. طيب even if you took R3 with the standard addition and standard addition of two vectors and the scalar multiplication, also if you took R4, if you took R5, he gave it to you now as what? As a theorem or as a rule. Actually, he put it like an example, but you can take it as a theorem. So why is that? أكيد, if I took any, مثلا, let's consider R2. If I took any vectors from R2, مثلا, for instance, مثلا, we take the vector -2, 3, okay? And the other vector, مثلا, let's take the vector 6 and 2. Okay. Now, if I added them, can I get 3 elements, for instance, or 4 elements? Well, the resultant is going to be a vector في R2 -2 plus 6, which is 4, and 3 plus 2, which is 5. Correct? So no matter what vectors you're going to take, you're going to end up by element from R2. ما حتجيبه من R3 ولا من R. So that means it is closed under what? Under addition of two vectors. طيب, does it matter if I added this to this or this to that? No. So any two vector, I pick them from R2. U1 plus U2 is the same as U2 plus U1. So the second one. The 0 vector, it is an element في R2 ولا لا? Yes. What is the vector that when you add any vector to it, you'll get the same vector? أجمع 6 to 2 with what to get 6 to 2? With 0, 0. So 0, 0, is it there في R2? أنا بتكلم عن R2 كexample. Yes, it is there. What is the inverse of 6 to 2? Is it an element في R2? Yes, it is -6 or -2. And also it belongs to R2 موجود وهكذا. So you will find all the 10 conditions are satisfied for R2 with the addition of scalar, the whole standard way, okay, of adding two vectors, while also when multiplied by scalar. This is what it is, a vector space. R3 as well with the standard way of adding, it is R4, R5, R17, okay, with the standard way of adding vectors and scalar multiplication also is a vector space, and etc. Clear? And the same as for the matrices. The set of matrices, M times M matrices, with the operation matrix addition and مش ضرب بتاع matrices, لا, scalar multiplication. Also the 10 conditions will be satisfied. And the same for the polynomials. What are the polynomials? Okay, and here of certain degree n. Okay, so in here, like here, set of polynomials, all of them of degree n. يعني مثلا 2x square minus 3x cube plus 4x to the power 5. Okay, so this is مثلا the first one. And the second one مثلا ممكن تكون minus 3x square plus 6x to the power 5. If I added them, I'm going to end up by one that is here or no? Yes. لأنه it is a polynomial and of degree n, اللي هو highest هنا a degree 5, etc. All the 5 rules you're going to find 10, sorry, then اللي هو adding a standard way of addition of polynomials, well, scalar multiplication if you multiplied this by a number like مثلا 2, I'm going to get 4x squared minus 3 في 4 ب 12 minus 12x cubed plus 4 في 4 16 16x. Yeah, it is an element here because only the constant are going to change, correct? And etc. So you will find all the 10 conditions as well are satisfied for this, for the polynomials, okay, of degree n, using the polynomial and the addition والmultiplication by a scalar. Okay, يبقى خلاص. We knew that these are vector spaces. Usually to prove that it is a vector space, it takes long. So it's much easier to ask you, is it prove that it is not a vector space? So let's see some examples here. Show that the set of vectors V اللي هم الvectors x, y such that x greater than y together with the standard operation of vector addition and طبعا standard multiplication by scalar. Prove that it is not a vector space. So we have this set of vectors. Okay. Together with standard way of adding vectors and the standard way of multiplying by a scalar. Prove that it is what? This is not a vector space. Type. We had before that what kind of vectors is this? They are elements in R2. طيب كل ال R2 plus this a standard way of adding, well, this is what? This is vector space. Okay, it's vector space. But this one, هل all the elements here are available here or some of them? Tell me. هل كلهم كل الelements in R2 are elements here or no? What do you think? Yes or no? هل كل element في R2 are elements here or no? No answer? Are you with me? معاي انتوا؟ طيب هل كل الelements الvectors في R2 are elements here؟ هل الست حقي ده V include كل element of R2 or part of them? And why? هل V كل R2 ولا a part of R2? طب give me example of one of the vectors that are here. Let me ask you. طيب الvector 1 و 2 like this. This is a vector في R2. Is it in V or no? Yes or no? 1 2 هل هو vector here or no? No. Why no? Because there is a condition here. The first element X always in that set should be greater than Y. But here X is 1 and Y is 2. So this element does not belong to the vector space V. It is in R2, but not in V. Clear? طيب. Now, what about the vector 2 و 2? هل هو a vector in V or no? Not in V because of this condition. It's clear now we're talking about certain set of vectors. It's apart from R2. It's not all R2. It is part of it. Type in this part only, we define the two standard operation. Now his question is it a vector space under these two operations or no? Huh. What do you think? طيب is it or no? We can prove it in different ways. For instance, احنا one of the condition قلنا شنو؟ بالنسبة لل addition of vectors لازم يكون 0 0 vector belong to V. So for instance, this one does not belong to V. It is not a vector space. So this is one way to prove. هل البروف ده صح ولا لا؟ Yeah, it is another way of proving. طيب, we said that, for instance, 1 و 2 it's not there, صح؟ طيب, now let's take مثلا 2 الفيكتور 2 1. يعني by the way, this way خلاص I can say like that. It's not a vector space because the vector 0 0 does not belong to V. Finished. طيب, now another way of proving. 2 1 belong to the vector space, correct? لأنه the x is greater than the y. Yes. طيب, احنا we said there are 5 conditions should be satisfied for the scalar multiplication. Now, what if I multiplied times minus? طيب, مثلا minus 2 times the vector 2 1. What is the resultant? The resultant is minus 2 في 2 is minus 4. Or minus 2 في 1 is minus 2. What do you think? Does this one belong to V or no? This resultant. And احنا عندنا الفيكتور 2 1 here, it's the vector there. But the resultant, this one, no. Why? Because still, is it x greater than y? No. So حصل شنو? Now this one is smaller. Minus 4 is smaller than the minus 2. So that means this does not belong to V. This is another way of proving. We said before, to prove that yes, it is, all the 10 should be satisfied, no matter what vectors you're taking. If you could find just one example that shows that one of the conditions does not work, you prove that it is not a vector space. And this example, we call it the counter example. We call it what? The counter example. Clear? And here he proved that it is not a vector space. How? He took x بتساوي 5 and 3, but minus 2 اللي هي حتساوي minus 2 minus 10 minus 6. So this one is not greater than that. This is smaller than this. So that means it's not belonging to my space. It's out of my space. It is here. This element, it is here in R2, but not in my space of vectors. اللي هو this one. It is not a vector space. Clear? طيب, here there is another example. Show that the set of vectors of R3, we define on them 2 operations. طبعا one of them we call it the addition, and the other one the scalar multiplication. But here he defined the addition of 2 vectors in a different way. By the way, this one is wrong. Huh? He defined it how? He defined it when you're adding this to this, use the new definition, which is how you add this to this, and then this to this, and then this one to that one. So what do you have? X plus, this is Y dash, and then Y, a vector, this one plus this one, the element is going to be Y plus Z dash. Okay, here this is Z dash. And then Z plus X dash. He wrote it here by mistake. Okay, so he told you that if we define this addition in this way, and the multiplication by scalar as per the normal way, our standard way of multiplying the vector times scalar. Type. Now, is this going to be a vector space or no? يعني now R cube under this operation, this is, we define it in a new way, and this one our old way اللي هو standard way of scalar multiplication. Is it going to be a vector space or no? طيب, we know that this one with this one there is no problem, because from before he said that R3 with the standard way of adding vector with standard way of scalar multiplication, it is a vector space. This is, I'm quite sure it's not. If there is a problem, it's not here. So I have now to test this. Okay, is it going to be as per this operation a vector space as well or no? So what I'll think مثلا هنا we have 5. طيب 0 vector, it could be an element there, ما في مشكلة. Every vector, what will come to my mind, okay, is if I took a vector and add it with this way of addition to another vector, the resultant is going to vary? لا. Why? Because again it's an element here. لأنه السبيس حقي هو R3 كل ال R3. So the addition as well is going to be where? Here. So it's not the problem. طيب now the commute. If I added x1, a vector, let's call it x1, to the vector x2, is the same as adding x2 to x1. So this I have to test it. Okay, let's test it. Okay, you can test it by an example or you test it in general. ما في مشكلة. If you could find it حتى لو كان example, even if an example was with numbers, it's okay. If it's not satisfied to that vector, then that means it's not a vector space. طيب, take any two vectors. Take any two vectors. مثلا, let's take 1, 3, مثلا 5, and take مثلا -1, like 2, مثلا 8 or 9 or whatever. Now, how we are going to add? We want to add this one to this one. Okay, and then find the resultant. How we define addition? How it was defined? We define it. This is as per the new way of addition. This is equal to what? 1 plus 2. So the first element is going to be equal to 3. Then 3 plus 9. So this is going to be equal to 12. And then 5 minus 1. So this is 4. Now, what if you commute? You change. Let's change. -1 and 2, 9. This is the first vector. The second vector, اللي هو 1, 3, 5. عملنا تبديل إبدالي. إحنا قلنا لازم يكون إبدالي. So now -1 plus 3 is what? Is 2. 2 plus 5 is 7. So it's clear it's not the same. 9 plus 1 is 10. So it's clear they are not equal as per the new way he took it or defined the addition. So that means it's not a vector space. He defined a new way. He defined a new method. Now, what I want to tell you that he can say, take the operation as they were defined. Or he may define for you a new way. And he asks you, if I define the addition in this way, is it going to be a vector space or not? You got the idea? يعني هي ممكن على حسب على كيف عايز يعرف له طريقة جديدة للجمع وعايز يشوف بالطريقة دي هي vector space or not. Okay? طيب يبقى you have to test as per the way he defined this operation. Okay? طيب, so it is not a vector space. It's clear. طيب. Here, show that the set V of vectors mean R3 together with the operations he defined. This is a vector في R3. How we multiply? He said to multiply. So this is going to be the first element and this is the second element, but the last element, R to Z, okay, when you multiply times no matter what is the last element, then he defined this to be 0. Okay, not the usual way, our standard way, our defined way for multiplication. Okay, is this with this operation اللي هو R3 defined on it the standard addition اللي هو the way we use it with vectors, and the scalar multiplication, this is new way, defined in a new way. Is it a vector space or no? يبقى شنو? We know that this one with this one has no problem. Always it's okay, because we had a theorem that R3 with the standard way of addition, well, standard way of scalar multiplication, it is a vector space. Type already this one, it is the standard. Now, if there is a problem, we'll raise from here, correct? اللي هو scalar multiplication. طيب, is it a vector space? إحنا عندنا 5 condition للscalar multiplication, correct? The first one, what? The first one, it's closed. That is, if you took any number R and then you multiplied by any vector, مثلا V1, the answer should be where? Here, correct? And it's clear. No matter what are the numbers here, I'm going to get, you know, this is a vector from R3. So it is closed under scalar multiplication. You have 5 صح of them. طيب, number 2, what? For instance, if you have R في S بعدين في V1, it is the same, you can distribute the same as that one. Yes, it's the same. Why? Because if هنا داير X1 Y1 وهنا Z1, okay, so when you multiply this times this times that, you're going to get the same answer, correct? It's حتى لما نضربه الاس لحاله في this, it's 0, then 0 في الار. So it's clear, it's not a problem, and you can check it by yourself. طيب, there are 5. You have to know them, remember them. Okay. So you will find that this is satisfied. This is satisfied. Now, the only one that will not satisfy, I'm telling you why, this one. Why? Because what? Because now, if we said what? When you multiply 1 times the vector V1, you should get V1. Type now, what if I multiply 1 times this vector? Am I going to get the same vector? No, because here the 1 في X by X, 1 في Y, but 1 في Z, it should be equal to 0. So it's not the same vector. It's not a vector space. You got it? So يبقى, yes, R3 under this new way of scalar multiplication, it's not a vector space. Clear? يبقى it's not a vector space because 1 في X is not, اللي بتساوي this is not equal to that, so it's not a vector space. طيب, now we want to define the subspace. Let's start بإنه we have a certain vector space, and in this vector space, okay, اللي هو vector space V, we took subset from it. We call this subset W. It is part of this V. And in this V, we have defined 2 operations, addition and multiplication, that makes this space what? A vector space. Now, we say that this space here, it is a subspace if it is, you know, subset from this one, and these two operations satisfies the 10 conditions here in this part. يعني معناها W with the same two operation اللي هو addition of vectors والscalar multiplication as well. This is satisfy all the 10 conditions. So if this is space which is part from the V, we say that it is what? It is a subspace. So is it clear what is a subspace? I'm going to take part of the elements of this, but all the 10 conditions for this operation and this operation, they should be satisfied here. That means if I took a vector here and another vector, مثلا for instance, and I add them as per this operation, the resultant should be when? Here, not here, not out. You got it? And the zero vector should be here, and all the 10 conditions should be satisfied. Clear what do we mean by a subspace? Type. Let V be a vector space and W be a non-empty subset of V. Non-empty has some vectors. If W is a vector space with respect to the operations in V, يعني أعمل لي إنه vector space with these two operations, okay? And since it is a subset, element حقته from this set, مجموعة جزئية من ده, then this is, we call it a subspace. Okay? We call it a subspace of V. It is a subspace of this V. Type. For instance, if we take R2 with the standard addition of vectors and scalar multiplication of vectors. Okay, we know that this is a vector space. This is my big vector space. Now, what if we took part from it? What is this part? It is W1. What are the elements that I'm taking from R2? I'm not taking all R2. What are they? They are the elements that the first element should be the same as the second element. How they look like? They like what? 1 and 1, correct? 2, 2, minus 3, minus 3, for instance, correct? Half and half, etc. These are the elements where here. Do I have مثلا an element 1 or 2? No. Why? Because he said that here X, here X. These are the elements I'm getting them from here. He said that this is a subspace of R2. It is a subspace of R2. That means what? All the 10 conditions will be satisfied. Clear? And if you want to test them, you will find that. Yani, for instance, if I add this to this, what I'm going to get? 1 plus 2, 3. And then 1 plus 2, again 3. So again, the element is where? Does it belong to W? Yes. It is an element here of W, صح؟ لأنه elements, how they look like. The first component should be this, like the second component, and etc. So no matter if you added these two together, what you're going, it is closed under addition. هل a zero vector, it's an element there? Yes, because the first is zeros. So yes, it is an element as well in the set there, and etc. All the 10 conditions will be. So that means what? W1 and W2 are what? Are subspaces of R, the subspace of R2. And this one, it is a subspace from R3. Why it is a subspace? Yeah, X, Y can be any two numbers, any numbers. But here, the last one is 0. So for instance, is the element 1, 2, 3, is it an element in W2, belong to W2? No, it's not. Yeah, it is in R3, but not in W, correct? يعني we have this R3 containing all elements, vectors that have 3 elements or 3 components. But W2 is a part of it. How the elements look like. يعني مثلا here, this one is not there, but the element 1, 1, 2, 0. It is an element there. For instance, -3, 5, 0. It is an element, and etc. Correct? This is how the elements of this set look like. Then he said, this one, yeah, it is, you know, a subspace of R3. A subspace, all the 10 conditions, اللي هم standard way of addition, scalar multiplication, okay, they will be satisfied in this part. Type. Now he gave you a theorem. To prove that it is a subspace, no need to prove all the 10 conditions. It is enough to prove what? First, that the space is not empty. At least it has the 0 element. Okay, in that space here, this is the vector space, and this is our W. So to prove that this is W is subspace from subspace, sorry, from V, it's enough to prove 3 conditions, that this set W is not empty. Not empty, at least a 0 element is a member there. 2, to prove that it is closed under addition of vectors. That means take arbitrary any 2 vectors. مثلا, let's say W1 and W2, arbitrary, any 2 of them. So the addition of these 2 vectors, sorry, addition, should be where? Should belong to W. That means يكون شنو? Closed under addition of vectors. The third thing, that is, if you take any vector arbitrary, let's say W1, so multiplied by any real number, let's say C1. So you have to find as well C1, W1 to be an element there. It should be closed for, you know, the standard scalar multiplication. For the scalar multiplication. So C1, W1 should be an element in W. So it's enough to prove this, because it's clear all the other 7 conditions will be satisfied automatically if it is happening here. So it should be happening there. From now on, if he asks me to prove that this it is a subspace of a certain space, vector space, then what we're going to prove? 3 things only. The first is not empty. That means it has at least the component 0, or the vector 0. Take any arbitrary 2 vectors, then you have to show that their addition is also in this space, W. 3, multiply any arbitrary vector times a constant, C1, then you have to show that the resultant of this, it is also as well, it is in W. Let's take our previous example, which we said that the set of vectors XX, where X is a real number, it is a vector, a subspace from R2. Let's prove that. We have to prove what? These 3 conditions, correct? That they are satisfied. The first condition, is it empty? It's not empty. Why? Because 0, 0. صح, احنا قلنا here and here should be real numbers. In particular, the 0 element is an element in W. So this belongs to W. Okay, so we proved the first. It is not empty. Is it closed under addition or no? Let's take any vector, you take them مش in numbers. If you want to prove, you cannot take examples. You take examples also only if you want to say that it is not false. Okay, here in this case. Type number 2. I will, take any vectors from this space W. For instance, let يمكن أقول له x1 x1 and I'll take them from W and x2 and x2 to be elements. They are both belong to W. صح? We take them because this is how W is defined. Here x2 down is x2, correct? Should be the same. Now, what if we added them? طيب, then the first x1 correct, plus the standard way of addition لأنه he defined the standard way of addition. Okay, with x2 and x2, what is the resultant? The resultant is x1 plus x2, correct? And here x1 plus x2. So what? The first element is the same as the second element. So always the resultant is an element in W. If we prove the second one. Now remains what? To prove the third one. طيب, what is it? طيب, هو let's take x1 from W. Now what about C1? هنا في الثالث. Okay, C1 if I multiply times the vector x1 اللي هو standard multiplication صح, scalar multiplication. Okay, how we multiply? So we are going to get C1 x1 and here C1 x1. هل element ده it is here in W or no? Yeah, it is in W. Why? Because this one is the same as this one. So yes, the resultant is in W. يبقى the three conditions are satisfied. يبقى yes, it is what? It is a subspace from what? From the big R2. يبقى this space W is a subspace from R2. And this is how we proved. Clear? طيب, let me do this example and then I'll stop. Show that W is equal to ABC such that C is equal to A plus B is a subspace of the vector space R3. طيب, عندنا the biggest is R3 and we know R3 define on it the standard way of addition and scalar multiplication is what? It is a vector space. Now I took a subset from it, this one, which is W. What are the elements in W look like? For instance, can I have the element 1 or 2 or 7? Is this element belong to W or no? Tell me. Does it belong to W or no? It does not belong to W. Why? The elements that are in W, if this is A, this is B, he said this element C should satisfy A plus B. So that means it does not belong to W. Clear how the elements look like? Type, what element belong to W? If this is 1 and this is 2, this one should be what? 1 plus 2, which is 3. So yeah, this one belongs to W. Give me other elements. مثلا لو كان ده -1 and this is 5. What is this one? Can I put any number? No. This number should be 5 minus 1, which is 4. So yeah, this one belongs to W. This is how the elements look like. Okay, of W. طيب. Now we want to prove that this set of elements اللي هم like this one, which are here, form, a subspace from this space. Okay, we said we have to test them with this. And to say that it is a subspace, we have to prove only 3 things. So the first thing should be not empty. طيب, if the first one is 0 and the second one is 0, so the third one, 0 plus 0, it is 0. So 0, 0 belong to W. It is included here, the 0 vector. So we proved the first, so it is not empty. The second thing, to prove what, take any two elements from here and you have to prove their addition is there. Type, for instance, if I took the first element to be A, let's call it A1, and this is B1. So this is A1 plus B1. So this element is from W. Take another one. So we have A2, B2, and their addition, A2 plus B2. Okay, yeah, these are elements were from W, yes. Now, what if we added them? What is the addition is going to be? The addition is going to be equal to A1 plus A2, the standard way طبعا. B1 plus B2. And this one is going to be this plus this. So A1 plus B1 plus A2 plus B2. I can rewrite it as, first one as it is, A1 plus A2, and then the second B1 plus B2. Here, this plus that, I need it, صح? So I can write this one and this one, correct? So it is A1 plus A2, okay? Then plus this two. I can arrange the things, صح? B1 plus B2. So yes, what is the result? Does it belong to W? Yeah, it belongs to W. It is in the form of them. The last one should be the addition of these two, correct? يبقى yes. يبقى, yeah, it is closed under addition. Is it closed under scalar multiplication? Yeah, these are the elements. Now multiply them times R. So R multiplied time this is going to be RA RB, and here R for all this. Now distribute it. So RA plus RB. So it is like that. So this plus this, isn't it this one? Yes. These elements belong as well to W. If the three conditions are satisfied, it is what? It is a subspace of this space R3. This is the standard way of adding vectors and scalar multiplication. So it is, it is a subspace. Clear what do we mean by subspace? Vector space and subspace. Okay, so we stop here, and next class we try to complete all. Okay.